get those lines of code to finally work after hours that just really make it all worth it. But yeah, moving on to our next project, we have Say What, a smart home energy management system with Shanice, Rachel, and Layla. So take it away.
Hi, thank you for coming to our presentation. My name is Layla and I'm from Atlanta, Georgia.
I am Shanice Gray and I'm from Greensboro, Alabama.
My name is Rachel Fariñas and I'm from Miami, Florida, and this is our project, Smart Home Energy Management System.
So here's a brief overview of what we'll cover. First, we'll introduce the problem in research, then move on to more specific details of the system. Finally, we'll finish off with a demo and future directions of the project. The reason why we created a smart monitor is because residential energy consumption is something that contributes to a significant portion of greenhouse gas emissions in the United States. Since the Industrial Revolution, residential energy consumption has dramatically increased with technological developments. However, many people are unaware of how much energy they waste. A lot of energy is wasted from the power line to the home, and furthermore, people generally do not heavily monitor how much energy they use. As a result, the United States has one of the highest household electricity consumptions in the world, and in the graphic on the side, we can see that heating, air conditioning, and lighting take up an astonishing 42% of residential energy consumption. In order to address this problem, we prototyped a smart home energy management system over the course of 2 weeks that is also known as SHEMS.
So here's an overview of how the system works. The system is meant to showcase how in-home lights can change based on the light and temperature outside for more efficient home energy usage. So the ambient light sensor or the photoresistor measures the surrounding light in lux, and these measurements are then sent to the microcontroller, which then changes the LED intensity of the white LEDs. And then that is sent to the Discord server, which notifies the user. And we also have the Open Weather API, which sends over the current temperature level outside to the microcontroller over a server. And then that is then used to change or to turn on either the red or the blue LED. And then that is also notified through the Discord server. So these are our project's components. We have the Adafruit microcontroller, which connects to a computer and then connects to all of the components on the board, such as the LEDs and the photoresistor. The white LEDs are supposed to dim incrementally according to the amount of light outside. For example, they would get brighter if it's dark outside. And then the red and the blue LEDs turn on according to the temperature and are meant to alert the user whether to turn on their AC or their heater. Blue obviously meaning that it's cold outside, and red meaning that it's hot. And then the ambient light sensor, the photoresistor, measures the surrounding light in lux. And the resistors, of which we have 3, are meant to regulate the flow of the electrical currents on the board. And the switch is supposed to turn off all of the LEDs once it's pushed. And then this is the schematic, which is an overview of the hardware of our system and how everything is actually connected. The photoresistor on the left, which is in green, is connected to an ohm resistor, which is then connected to the microcontroller. And then on the right, the red and the blue LEDs, which are in the appropriate colors, are each connected to are each connected to a regular resistor, and then are connected to the microcontroller. And then the white LEDs, which are in black, are below the red and the blue, are directly connected to the microcontroller. And then the switch on top, which is in yellow, is meant to turn off all the LEDs once pushed.
Data collection. First, we use the photoresist to measure the brightness and lux from outside throughout the day. Second, we analyze those measurements. When analyzing those measurements, it helped us set the desired measurement to control the dimming and brightening of the LED, the white LED. Thirdly, we compared the desired measurement to the real-time brightness from the photoresistor to set the white LED accordingly. Additionally, we use the Open Weather Map API to get temperature data for red LED, meaning hot, and blue LED, meaning cold.
In order to change the brightness of the LEDs, we use a technique called pulse width modulation. Essentially, this is a technique used for controlling the power delivered by the microcontroller. It involves changing rapidly between two values in order to get an intermediate value. In our case, it was switching between on and off to get an intermediate value that was the brightness of the LED.
We use a if statement that changed the brightness of the white LEDs based on the brightness outside. For example, if it was early morning, being that the sun hasn't risen, which was determined to be lux is greater than 100 but less than equal to 440, so the white LED would be at 80% brightness. As you can tell from the diagram, as the brightness outside went up, the brightness of the white LED went down. Also, the LED will be at 100% brightness when a switch is pushed and 0% when it is pushed again. As mentioned earlier, we use the Open Weather Map API to control the red LED for hot temperature and blue LED for cold temperature. Since we are all in the Southeast, we set blue LED to turn on when temperature is less than or equal to 78 and set our red LED to turn on when temperature is greater than equal to 79.
So we also prototyped a social media component to our project, which serves as a notification system. We decided to use Discord, which is a messaging app, as a way to send notifications to the user. And we also used an Adafruit IO trigger, which was supposed to be scheduled. And so every hour, the user would get notifications as to the status of the lights and the intensity. And we weren't able to fully implement this feature, however, so it's only a proof of concept.
Here is our demo, and I forgot to include the switch in the video, but it does work.
So our light should be at full brightness and our red LED should be on for being hot. It is currently 7:03 a.m. Our temperature is 75 degrees Fahrenheit, so our blue LED should be lit. Our photoresistor is picking up in the 180s, so the LED should be second to full brightness, so it should be slightly dim. It's currently 9:18 a.m. Our photoresistor is picking up lux in the 500s, so our LED should be at third brightness, which is lower, slightly dim from the second brightness. Currently 9:17 a.m. Our photoresistor is picking up lux in the 600s. So our LED should light to its fourth brightness, which is slightly dim from the third brightness. It is currently 9:21 a.m. Our photoresistor is picking up lux in the 900s. So our LED is at its fifth brightness, which is the lowest brightness. It is currently 9:09 p.m.
As you can see, although SHEMS is a relatively simple idea, it has the potential to make users more conscious of their energy usage, which is really valuable with the increasing threat of climate change. In the future, we would like to incorporate SHEMS into actual house lights and research its impact on home energy usage. Furthermore, we would want to create an app that gives users more insights into what's going on with the SHEMS and also allows them to have control with their lighting. Thank you all again for coming to watch our presentation. This was an amazing and meaningful project to work on, and we would like to thank Joe for his support throughout the past few weeks. With that being said, does anyone have any questions?
Great job, really great job. And I'm one of the science writing instructors. And from that standpoint, I loved the way that you set up your presentation and you brought it home at the end. I loved the beginning where you were talking about you explained the problem and you talked about energy use in the US and in Canada, and then went into your project, and then you brought that back at the beginning. But I'm a science writing nerd, so I'm going to like that. But, I think that's important for all of us to remember in presentation, in that, it's smart to tee up your project and explain why it's important, and then go into your project and then bring it back home again. So as I say, as a science writing nerd, I appreciate the way that you handled your presentation. So talk about this a little bit. Talk about the problems. I asked the other groups about the most vexing problem you had. Was there something here that you guys stumbled on and that you had to kind of struggle with? What was that?
I would say that we had a bit of an issue with the pulse width modulation. It's a bit difficult to figure out how to change the lights incrementally according to the light intensity outside. At least that's what I thought was one of the more difficult parts of our project.
Great. I'm looking here because I'm working a little bit backwards on my site, but one of the questions from the site, you're currently using temperature from the weather site. What other weather information could be used in a system like this? I think there's other weather systems that could be, or weather systems you might use.
I would say we can get from the Open Weather App API, we can get the current weather from outside. So like if it's storming or raining, it can notify the people on Discord that what it's doing outside.
Mhm.
Also. And it can also take in the how many clouds outside. If it's few clouds or very cloudy or few or scattered clouds, it can also notify on the Discord too.
Sure. What made you choose Discord as your notification messenger over other applications like text messaging or other projects?
Well, personally, all of us use Discord, and I think that in general, Discord is a really popular messaging app that people check really frequently. And additionally, Discord has the ability to like ping everyone. So we felt that it would probably be the most helpful to the user.
Excellent. We got a couple more minutes here. You stated you wanted to incorporate SHEMS into actual house lights. Did you research any possible methods of this integration that you would want to share?
No, we haven't, but I do know, I'm pretty sure that Apple does like a collaboration with Amazon lighting. I can't remember the exact details, but I do know that there are already some systems on the market that do something really similar to the product that we created.
Excellent. I think that's the questions, all the questions that I have in the poll system. I'm jumping back and forth here, but I think you guys did a great job. And I don't know, Carlos, if we've got anything else, but nice work.
Can I jump
Please.
in real quick? I just wanted to say, like, I thought this was a super cool presentation. And I agree, like the Discord, like when I saw that you guys had set up like a Discord bot, like I thought that was super cool because like, I mean, like she said, like we're all on Discord. So I thought that was like a super nice like integration. And I think especially like now, like getting notifications to your phone is like such a popular way to like follow habits and keep up with things. So I just thought it was super cool.
Olivia, awesome. Thanks for chiming in.
Yeah. While the next group is setting up, I mean, I just want to agree on Olivia's point there. My group of friends and myself have also been setting up our own Discord bots. So seeing those integrations, especially with an API that's pretty friendly to having new modifications, it's a really smart move, especially moving into the applications that we're using more frequently. But yeah, if the next group wants to start sharing their screen, I believe this next project that's coming up is from Amr, Brian, and ZQ. And it seems like they're doing a play on